Okay. But anyway, we certainly do have a very interesting topic today about environmentally friendly shipping. We have been talking about the environment and the challenges, the changes that are going on. And today we are going to focus on the shipping industry and what the problems are and how we can find solutions. Um, and this is really a topic for the future. As I said before, one of the purposes of this course is to make Korea more competitive in shipping again, because it is such a tough market out there, isn't there? So one has to be at the frontier of technology and now know how, in what directions, the directions that are becoming more important, and certainly the environment is now a heading for very much new trends in shipping. And as you will see as I go through the presentation during these 2 hours, there are so many aspects of environmental performance and so many things that can be done. And of course, some are more important than others, but in the end, it's really the sum of contributions from different sectors within shipping that will give the important final result. So if we now try to couple this to what we talked about the last time, about the climate change, and we talked about climate models. And there's one term that is being used internationally when it comes to characterizing and quantifying the climate effect of activities. And that is what's called forcing. You know, as engineers, we know what a force is, but in this context, the force really means influence, right? The influence on the climate. And in particular, as we were talking about, the climate and the greenhouse gases, right, has to do with radiation more than anything else. Not insulation that some people think, but it has to do with radiation. So if you look at the influence from human activities, and one can characterize this in terms of this forcing effect, that is the effect on the radiation in the atmospheric layers. And you see here we have long-lived greenhouse gases, CO2, CH4, that's methane, and other types of hydrocarbons and so on. Ozone, oxygen in a particular chemical form. But there are also activities that kind of have the opposite effect, kind of a blocking effect. And so you can talk about a positive forcing and a negative forcing. And in the end, we are interested in, let's say, the net effect of the human activities when it comes to influencing the conditions in the atmosphere, and of course, as a function of that again, temperature and climate on Earth. So there's something called albedo, and the ratio of reflected to incident light. That is, when a light comes down to the Earth, and you see the Earth from a satellite, it's the reflected light you see, of course. And of course, there's also the inverse effect when this radiation comes from the Earth up towards the layers, then things are sent back again. And that's a main problem. So how much is reflected and how much is sent down again is really what we are interested in. And of course, that has to do with what comes out of the chimneys for our ships, and as well as many other things. So you remember this one I showed the last time is just to tie what I just said now with this reflection type of activity and the fact that our human activities influences this layer around the Earth, and thereby also changes the climate. So there's really a lot of very complicated technology going into this. And one of the most complicated things is also the chemical reactions that take place in the atmosphere under certain conditions. One is also talking about the half-life time of these gases. For instance, when you send CO2 up into the atmosphere, it doesn't stay there for forever. It's gradually disappearing, but of course we are feeding all the time more and more CO2 into the atmosphere, right? So it's kind of the net effect of disappearance and feeding new CO2 that is the mechanism. But one can also go from this forcing function that we just talked about into what does it mean in terms of temperature alteration, change of temperature on the Earth. And even though this is an extremely simple equation, the reality is very much more complicated. And as I said also the last time, these mechanisms are not fully understood. And this, for instance, the CO2 cycle, where the oceans are a very much important part of the CO2 cycle, it's not fully understood yet. So let's look more and more into shipping now. And what do we have on our conscience when it comes to pollution? Well, CO2 emissions from the world fleet has been steadily growing. And then one can make projections, right, based on these scenarios. We talked about the ICCP, the Intergovernmental Panel on Climate Change, and they have made different scenarios. And depending on which one turns out to be right, one can have forecast smaller or bigger growth of CO2 emissions. And then, if you look at the problem, we are getting more and more concerned, of course. And for instance, the European Union, they have set a target for reduction of CO2 by 20% by year 2020 in relation to year 1990. So if you look at 1990 and you are going to have a 20% reduction, then you have to get down to this level, right? And all the predictions, they go up like that. So there is a big disparity, a difference between what is happening and what the political goals are. By the way, this EU target not only is talking about a 20% reduction of CO2 emissions, but they're also talking about the 20% renewable energy as a part of the total energy usage. So there are some very challenging targets, and the way we are going certainly is not exactly according to what we wish. But we can do something, and that is important. So we are looking for solutions, right? So how can shipping reduce greenhouse gases? Well, incentives and regulations. Incentives is something you do to encourage, right? One incentive could be, for instance, lower taxes, right? And regulations, that is requirements. You know, you shall not emit more than so and so much, right? And you are not allowed to do this and that. And of course, when it comes to shipping, it's in one way much more difficult than any other industry. And why is that? Well, it's because it's so international, right? So it doesn't really help if one country regulates that the ships under the flag of that nation has to do this and that. Then probably the ship owner would change flag, right? So what is needed is international agreements. And we have organizations like IMO, the International Maritime Organization, and I would encourage you to look up, for instance, the web pages of IMO. The headquarters are in London, and they have a lot of regulations having to do with safety, but also maritime pollution, MARPOL, and another series of other regulations as well. So they are coming into force, and they are international regulations. So that's the way to go through these, for instance, United Nations type regulations. We have UNFCCC, United Nations Framework Convention on Climate Change. That's the organ that organizes, the Kyoto meeting, the Copenhagen meeting. Later this year, there will be a big meeting in Cancun in Mexico, where all the countries of the world essentially come together to see what they can do with the climate. And last year the meeting in Copenhagen resulted in almost nothing. They more or less agreed on continuing to work towards new regulations. But so it goes kind of up and down in this respect. But in the long term, certainly there will be stricter and stricter requirements, and one has to comply with these international regulations that are put into place. And for instance, European Union has an emission trading scheme under development, port use, new taxes, and so on. So if the organization not necessarily is world or spanning the whole world, it can still do something. In one way, I'm just as interested in the voluntary arrangements. For ship owners, for instance, it's more and more now turning into a good thing to profile environmental awareness and initiatives. Even the cargo owners, you know, the big cargo owners, let's say the oil companies that ship oil from one place to another, they don't want to be associated with a lot of pollution, oil spills, and that sort of thing. That taints their image. And people start protesting. They won't buy their products. So, so that is also playing into this. And ship owner, green shipping clusters, green shipyards. I think this is something that will be important in the future, that shipyards, they say we are environmentally aware, we take care of our waste products, we build ships that are using, let's say we are using minimum amount of energy in building the ships, and we are designing the ships so that they become more environmentally friendly in operation. And then there are things we can do, not at least based on research. Improve efficiency and ship operations and fleet and voyage planning. Logistics optimization, I'll come back to this. Enhance technology, ship design, engine efficiency, alternative fuels, cleaning technology, and so on. So we have kind of three main areas where we can work with these environmental challenges. It's through incentives and regulations, voluntary arrangements, and technology and better systems. And again, system engineering is certainly extremely relevant when it comes to dealing with the environmental challenges. Do you know the expression carrot or stick? It's well, it's kind of illustrated here. You know, you have a donkey who doesn't want to walk, right? He wants to stand still. And you can do two things. Of course, you can tempt the donkey to go forward by hanging a carrot in front of it, right? The donkey wants the carrot, okay? So that's, you know, that's kind of the positive reward, right? But then alternatively, you can hit the donkey, right? So you know, it feels the pain if it's standing still. So that's the expression carrot or stick. And in one way, I would say that, you know, the carrot is certainly a more positive way of dealing with this challenge. But there are some very, very stubborn donkeys or ship owners who don't want to do more than they have to, right? So they have to be punished or forced to move ahead too. So some ship owners, they like to operate this kind of ship. And that's an expression, a rust bucket, you know, can sink any time if it looks terrible. And then you have people and organizations that are really focusing on new and environmentally friendly technology. For instance, ferries that are running purely on LNG. And of course, as we talked about, LNG is a low carbon fuel. It has hydrogen to a large extent, so it emits much less CO2 per energy unit than typically if you burn oils or even diesel. So I think more and more people are beginning to realize that the winners will be those who are not reluctantly having to comply with the latest regulations, and they don't do it before they have to. It's really those that are going to be active that will position themselves for success, so to speak. Of course, if you are going to put the resources in the right places in order to improve the environmental performance, you have to understand what is going on. And one can, for instance, put together a model, a mathematical model for the world fleet, right? And we have data, we have talked about data for the world fleet. We know something about the power, the engine, and how the various ships operate, how much they have to transport, and on that basis you can do some estimates of fuel consumption, and then on the basis of the engine data and so on and fuel data you can say something about emission, and you can say something about how much is emitted altogether. But of course, if you know something about where the ships are trading, you can also say something about, you know, where you have most traffic and where you have most emissions. And thereby you can model the impacts. So in one way you can say, when it comes to the pure climate greenhouse gases, it doesn't really matter where you emit them, right? Because they go up in the atmosphere, and that's where they do the damage. But there are other aspects like sulfur particles, and in one way shipping is a good thing, because most of the shipping takes place far out at sea, right? Whereas if you think of transporting by truck, where do the trucks run? That's where people live, right? So in one way, emissions from trucks or cars are much worse than emissions from ships that trade internationally, because you have the local effects of pollution, and not only particles and chemicals, but noise pollution and safety aspects and so on. So we shouldn't forget that shipping also certainly has many advantages when it comes to moving large volumes of cargo. But anyway, the point here was that we can make models, and on the basis of the models, we can also feed this into what's happening in relation to the scenarios and so on. I won't spend too much time on this, but if you're interested, of course, there is literature that you can study on this topic. And for instance, I mentioned that when you know where the ships are trading, and what the frequency and the size of the ships, what the engines produce in terms of pollutants, you can make maps. You can see very clearly where these emissions take place, right? And you can also not only look at the totality, but you can look at the growth and the areas you see have let's say, the worst impact. And of course, if you talk about regional trading, one can come up with transportation schemes that are more efficient. And that has to do with fleet utilization, how you utilize your ships in order to, let's say, have as much efficiency as possible in your fleet. And this one is quite important, this slide, and I would encourage you to look more at it later on. And it's really dealing with where can we potentially reduce CO2 emissions by various measures, right? So it's the efficiency and optimization of new ships, stepwise switch from heavy fuel oils to marine diesel oils, for instance, that certainly are not only when it comes to CO2, but also when it comes to emission of sulfur is very important. Optimal hull shape. And this is compared to year 2000, and this is based on an article that was published in the year 2000. So it's, in one way, it's a little bit old, but what we can see now with modern ships is that we are about to reach this kind of improvement compared with ships from year 2000. And when it comes to hull shape, there's a significant potential for saving fuel by reducing the resistance of the ship. And of course, what you do typically in the ship model tank is to kind of optimize the shape of the ship, including the bulb and the aft part of the ship, you know, how the inflow to the propellers and that sort of thing. So there is a significant potential. And if you say 10%, well, 10%. Well, of course, if you look at the world fleet, and if we really were to have optimized ships, and they, because of the shape, use 10% less fuel, that's a tremendous saving. So these numbers really add up. Propulsion systems, maintenance of the hull propellers, that has to do, for instance, with marine growth and, you know, the surface being, you have more surface friction and so on. So from purely technical measures, one, according to this study, and of course it's not necessarily the ultimate answer to this problem, but it is a good indication, and the indication says that it will be possible within a few years to save about 30% of the fuel if we were to implement all these various actions that are listed here. That's quite significant. And then there's another one. And this is also about to happen now, and that is speed reduction. It's kind of the opposite of old thinking, right? The old thinking was, if you go faster, of course, then you can transport more on the ship because you spend less time going from A to B, and thereby you can cover a longer distance and more ton miles in a year. So, but for various reasons, one may be, let's say, the will to reduce pollutants. Another one is that the fuel price is going up, right? So what is economical is not necessarily the same answer now as it was some years ago. And there's a small potential for improvement also if you try to avoid severe weather conditions and so on. But it's quite interesting. If you look at some of the trades, for instance, ships going to Australia, and they go full speed to Australia, and when they come to Australia, they find that they have to wait 10 days before they can unload their cargo. That doesn't really make sense, does it? But they go full speed because they want to have a certain slot in the queue, right? The earlier they come, the earlier they can deliver their goods. But if you look at it as a system, it's really ridiculous. You know, that ship could have gone slow speed, been there just in time to do the unloading, right? It saved a lot of fuel. But that's not the way it is. So things have to play together. Do you know the expression a cluster? You know, in economical modeling and, let's say, modern management theory, one's talking about companies being part of a specific cluster. And that is, a cluster can be organizations and companies of various sorts that are playing together. And in shipping, more than almost any other industry, clusters are extremely important. And there are many organizations that have to play together when it comes to carrying out the international shipping operations. So you have the shipyard owner, the crew, the operator, which can be different from the owner, the cargo owner, you have the port authorities, we have the canal authorities, we have interaction with inland transport, designers, equipment suppliers, universities, authorities, class, fuel, brokers, selling, buying. So it's a very complicated cluster. And what one could hope for is that all of these organizations together realize that something can be done with respect to the environmental performance. And you may end up, even as an owner maybe, in almost any of these positions, right? So that's why I think it's important to understand that this is really working together towards a common need. We talked about becoming more important to do profiling. And there's one ship owner in Norway who's done this to a very large extent at a relatively low cost, because they have had an internal project on the emission-free ship, and they have called it, for some reason, Orcelle. I don't know why they called it Orcelle. But it should be efficient cargo carrier, some kind of bulk cargo, mixed cargo ship, alternative sources of energy, You can see something here that looks like sails, and or at least wings, and or airfoils, if you like, covered with what do you sun. What do you call it? Solceller in Norwegian. Photovoltaic. What do you call it? When you convert light into electricity. Solar panels is the solar panels covering these airfoils. No ballast water, and that is certainly possible to have a ballast water-free ship. No emissions to the air, no emissions to the sea, no oil spill if damaged. And I've included the website if you want to look further into this. But in reality, this particular thing is more than anything the public relation department of the ship owner that has been pushing this. We are quite far away from seeing such a ship today. But I think it's important to have a vision, and this is a good vision. So one can go ahead with maybe implementing certain aspects of such a vision. We talked about ship speed, and when it comes to resistance of a ship, you'll see that the resistance, which is also tied to something called the Froude number, and some of you may know something about that, but in essence, the larger the ship is, the more efficient it becomes in terms of resistance in relation to the size. Okay? And if you look specifically at container ships, and that is, as we know, the fastest growing major shipping sector, you can see how much is released in terms of CO2 per transported unit and length, right? That's kind of ton mile. How much CO2 per ton mile, or per container, if you like. And it's different sizes of container ships, from 2,000 TEU, which is the standardized container units, 3,000, 4,000, up to 10,000, and we're now today having ships up to 15,000 TEU. But you can see, of course, as the ship gets bigger and bigger, the amount of CO2 per unit and transported length goes down, right? You see these curves, and here we have the different speeds. And typically a small container ship would operate with a lower speed than a large container ship. So the black curve is showing what is the typical average speed of a ship of a given size. So it's clearly an advantage by going slower, as well as having a larger ship, right? So if you go slower, of course you move this way, down the curve, down the curve, down the curve for the various types of ships. And we also see from this that it's quite advantageous to have larger units. And of course, larger ships going slower. one can also analyze different types of ships, compare them, bulk carriers, and you have the size and the installed power on board. And you see that for container, you typically have a large emission per ship because you have such a great power. You have big engines on a container ship in order to go relatively fast. Whereas an oil tanker, of course, is in itself very big, but it doesn't go very fast. So this is just a picture of power related to the ship type. And you see some remarkable things here. You have some small ships that have a lot of installed power, and this is for offshore service vessels. And you have one on tugboats that's also very high. I'm not sure where that is. It's kind of blurred, but maybe that's tugboats, and that's, well, anyway. There are some ships, of course, that have great power and thereby also, in spite of their small size, emit quite a bit of CO2. But we have to be concerned about much more than just CO2. So what goes out of the chimney, we have to some extent talked about. We have emissions from various gases on board and vapor from the cargo. We have sewage, garbage, oil spills from the engine room, ballast water, and we'll talk more about that. Anti-fouling paints that have toxic components and which can damage the environment. Bilge water, tank washing also can give some very bad discharges to the sea. So it's a very, very faceted problem, many-faceted problem, and one has to be concerned with all of these various factors relating to the environmental performance of ships. So this is more or less the same sort of thing listed. So it's greenhouse gases, NOxes and SOxes, particles, ballast water, antifouling, oil and water, wastewater, other wastes, and of course also in the last phase of the life, when the ship is brought to shore to be scrapped, then there are many dangerous materials that certainly has to be handled in a proper way. And we talked about these various aspects already, but some are having to do with technology, some have to do with how you operate your ship, that's the red, and the green has to do with the logistics. So, and we have seen some numbers for how much you can gain. Remember that chart with the potential savings you can get from improving within these different segments of performance. So by slow steaming, there's an example here, and this I picked up from Maersk Line's homepage. And Maersk Line is the world's biggest container carrier. So slow steaming helps reduce the carbon footprint of our customers' supply chain operations, of course, their own footprint as well. From 2007 to 2009, we managed to slash CO2 emissions per container by 12.5%. And we are aiming for a total reduction of 25% by 2020. Slow steaming will be a key in reaching this target. But it also means when you go slower that you need more ships, right? Maybe if you, on one particular trade, used 6 ships, you may have to use 8 ships. So for the shipbuilders, that is good news in one way. One has to build more ships, right? But the net effect on the pollution is very positive. Yeah, I think I'll skip that one. Okay, so we are ready to start again. Where were we? Oil spills is the next topic. And we are talking about 2 types of oil spills. One has to do with operations. So tankers routinely clean their tanks when they go empty back to get some more oil. And unfortunately, it's quite common practice to discharge this into the water, into the sea. Most of these are relatively small, but again, the sum of it is quite significant. So it's quite bad. And some releases are intentional. And that is, even sometimes they dump a part of their oil cargo on the sea, and of course this is absolutely unacceptable, and it tarnishes the reputation of shipping. And then of course there are accidents, collisions and grounding that can give rise to very large oil spills. And of course nowadays, with modern media and television, we will get to see this very, very quickly. And sometimes what you see on media is maybe a little bit out of proportion in relation to what has happened. But anyway, there can be severe damage. And of course, Exxon Valdez, I'm not sure if that was how many years ago? So more than 20 years ago. So you were barely born. But it's the big oil spill, if you look at shipping history, in terms of attention, but not in terms of size. So, you know, this happened in Alaska. The ship was full of a new oil cargo, and it went on ground, and partly because the captain was drunk. So very embarrassing. And this was a ship with oil cargo for Exxon, and the ship was owned by Exxon, and Exxon really had to pay a lot of money and lost reputation, certainly among the public. Another case, a little bit more recent, 1999, the Erika, and that also was a very dramatic accident where a ship, a old tanker, broke in two during a storm. And of course they shouldn't do that. And oil spills along the whole Bay of Biscay, France and Spain. And oil is still leaking out from that wreck. So if you look at some of the statistics and how much is spilled per year, so about the 24% of the global input of oil into the marine environment has to do with oil transportation and shipping. So that is not the whole truth, because there's natural leakage of oil into the sea, and of course there's oil coming from ports and from rivers and sewage systems and so on. And 20 to 30% of the shipping oil is large oil spills. But there's fortunately a very positive trend. And here you see the statistics, how much oil in thousands of tons has been discharged through oil spills, larger than 7 tons, over the last 40 years. And you can see some particular accidents. The Atlantic Empress, here's a big one, 252,000 tons, Castellón. And this is, so when you look at Exxon Valdez, it's this one. It's really quite small, but among the image of people, you know, that is the big one, because it happened in, first of all, the United States, and it happened in an area that was, let's say, the nation was rather vulnerable to oil spills. But even the same year, there was another oil spill, this one, that was greater than Exxon Valdez, and people didn't care too much about that. And some other ones. Here is the Erika that also received a lot of attention, etc. But do you see the trend? That is very, very encouraging. And why do you think that that is the case? Because the amount of oil that is transported on ships is going up all the time. And that is better operations, better ships, better planning, and of course, better education of people who operate the ship. And when it comes to the more physical barriers as a part of the safety system, I'm sure you're all familiar with the concept of a double skin or a double hull kind of design, which has been an evolution since, let's say, the first tankers had only a single layer of steel that was the barrier between the cargo and the sea. Here you just see some of the framing inside. Then the concept of double bottom. When does that help? When you run on ground, right? Then typically you hit into a rock or something. So that is good for that purpose. And of course, if you also have double sides of the ship, then you also have two barriers in relation to collisions. So the requirement now is for all ships, new ships, tankers as well as bulk carriers, to have a double skin, double barrier. And according to IMO, the ships that are of older type and do not have the double barriers, they have to be phased out. And you see, 2010, this year, is the last living year, so to speak, for ships that were built in 1984 or later. So by this year, end of this year, we should not have any single skin type oil carriers. Ballast water. And why do we have ballast water on ships? Well, it says something here about safety and stability. Why does it have to do with safety? Well, of course, the safety and stability can be part of the same thing if your stability criterions are not satisfied with sufficient safety margin when the ship is empty, then of course it's a safety issue. But just as much, it's a matter of the propellers. The propellers have to be down in water in order to work. And then there have been some cases where ships have gone out to sea with the propellers only partly submerged, and then they have hit a storm, bad weather, and they haven't had enough power, so they have gone aground. The wind has carried them to shore. So it's very important to have sufficient draft, be deep enough into the sea for the propellers to work, and as well as stability. And when you look at the big tanker, it's tens of thousands of tons or tens of thousands of cubic meters in ballast water. And here you see about 35,000 millions of tons per year in discharged ballast water. And that brings with microorganisms as well as bigger species, and that can create damage to the natural ecosystem, and it also can imply danger to human health. For instance, diseases have been spread by ballast water. Typhoid, been one case where one ship spread typhoid from one city to the next as it went on its voyage. This I don't think I have time to go into in detail, but it's important topic. How do we deal with ballast water? And what is happening now is that IMO are introducing very strict regulations for ballast water, which essentially implies that when you come from one part of the world to a new port, and of course then you may want to take cargo, so then you want to take out the ballast water. You are not to dispose of untreated ballast water at port. So one can do two things. One can exchange the ballast water out at sea, take fresh clean water out from the middle of the sea, and get rid of the ballast water that was acquired at port, some other place, and then supposedly that will be clean enough. Or one has to clean the ballast water before it's discharged into the water at the port. And this, when you talk about tens of thousands of cubic meters, that is a big big effort in terms of energy, as well as it's a big problem in terms of use of chemicals and the use of equipment. So one can deal with ballast water by chemical enhancement to obtain, for instance, coagulation, that things lumps together, and one can spin it in a cyclone, filtration, and then chemical treatment with chlorine and chlorine dioxide, ozone. But you know, these things are not very good for the ship, the piping of the ship, etc. And so it may lead to corrosion problems and so on. But one can also use ultraviolet irradiation, deoxygenation, what does it say? Gas injection, ultrasonic treatment. There are systems where you kind of make so much acoustic noise in the water that you kill the microorganisms or bigger organisms simply by sound. So it's worse than earplugs. So there are many systems, and this you may want to look into, some of you, in connection with the homework you're getting. For instance, now for cruise industry, the dealing with waste sewage is a big challenge, because it's not acceptable that you dump these waste into the water, and if you do, you are probably getting the coastal state or the port state on your neck, and you'll be fined. So, you know, this has to be dealt with through procedures and systems on board. Many types of garbage, and I also mentioned recycling as a source of pollution and quite a challenge. I'm a little bit surprised that there has not been more technological development in this aspect, because you know, the way scrapping of ships take place nowadays is that, well, in many cases these old ships are brought to India. Have you heard about this? And they're run on shore, you know, on the sandy shore, and then people come out and by mechanical means and with burners, and they cut out the steel pieces and the various parts of the ship, and with very low tech help. You know, it's very dangerous work. It's toxic environment, and it's not a good way of dealing with it in relation to the beaches either. But that's how most ships are dealt with today. They are sailed to countries like India, where there are people with very low wages are carrying out the scrapping of the ships. So in one way, that is unethical. You know, these people are, I would say, in many cases exploited. But they don't have much alternative, so they do it. But why not cut up the old ships, having some docks and robotics and modern logistic systems, IT systems to do this? You don't have to have much human interference with modern robotics. So maybe that could be a new market. And of course, to reuse the materials of a ship is in itself a resource that should not be wasted, right? But some components, so particularly older ships, you find asbestos and very bad materials. And of course, using robotics would be a much better thing than to send people in to tear out the panels with asbestos and so on. Yep. I think I've covered much of this. So there are many measures that can be done. But if one could also deliver wastes at port in a better fashion than what is the case today, and there should be some incentive schemes to deliver the wastes from a ship, as well as the stick penalties for breaking the rules. And also doing the scrapping in a more environmentally friendly way. So, we are talking about so-called S-curves when it comes to technology. And by a S-curve, we mean we have time, as time goes by in one direction, and then we have a technology performance. So, if you look at sailing ships, with better sails and larger ships, they became more and more efficient. But then, towards the end of the 19th century, sailboats were not really that attractive any longer, because we had the steamships, first paddle steamers, and then we got steel ships and propellers and more efficient technology with steam and then the diesel and the other engines, motors burning oil came about, and we see this S-curve also in terms of performance that we can expect from a motor ship. So the question is, what is next? Not burning oil, hydrogen, natural gas, fuel cells, nuclear power, solar energy, wind power again. Well, not in the old way, I guess. So let's look at that. We have fuel cells, for instance, and if we go back to this report by Schulsvik that I showed you, what is the potential of reducing emissions by technical measures? Fuel cells could be one such technology. Marine diesel engines, more and more, rather than burning these sticky heavy oils. And one problem actually with ship engines and the heavy oils that have been used on ships is that, well, not only is it a low quality oil, some cases it's, the oil is so heavy that you can shovel it with a shovel. You have to heat it up before you run it into the engine. And not only that, it turns out that in some of these sources that deliver these marine fuels, they mix toxic wastes into the oil. And that's one way of getting rid of some problem materials. And that, of course, is very bad. But, of course, also when it comes to the fuels, the sulfur content is very important. And there are coming new regulations for reducing sulfur content in marine fuels, which, of course, is a very good thing. But what I have heard is that if one were to implement that as a regulation right now, and it is coming in a very short time, there is not sufficient refinery capacity in the world to be able to deliver all these much cleaner fuels and oils bunker oils for the ships. So things are very often not quite as simple as they may seem. Let's see. How do I do this? Is that one? Yeah. Okay. Well, we are beginning to see these fuel cells more and more in buses, cars. Some ships are very small ones, or underwater, are operating with fuel cells, and there are these main types of fuel cells. Unfortunately, some of them require some very expensive metals and rare metals, and typically also fuel cells do not have very long life. They have to be scrapped after a certain years of usage. So that there are still many problems with fuel cells. But there have been some projects. There was one in Norway I would like to mention. That was called Fellowship, and a consortium of industrial participants, including DNV. And the first ship with a major installation of fuel cells is this one. A Viking Lady was delivered last year, and the auxiliary power, that is not the main engine, but it's the other energy needed on board, was installed. So it delivers 320 kilowatts, it says here. Yeah, so it runs on liquefied natural gas. But of course you can also use liquefied natural gas or natural gas in a combustion engine, which is simpler. But with a fuel cell, you don't get the same amount of CO2 release as you get when you do it in combustion. Gas ferries, and I think in Norway we have pioneered gas ferries. This is the first one that was delivered about, I think it was 9 years ago. And now there's a series of ferries in Norway that are running on an LNG. And there's a system being installed along the coast where they have stations with storage of LNG on land. So refueling is becoming more and more available. And of course, these they have much less release of CO2. So it's much more environmentally friendly. And I showed you another picture of Fjord 1. I think that's the latest in this series of gas ferries in Norway. I'm sure you can find that on the web, also in English. And I think that Fjord 1 ferry carries about 250 cars and 500-600 passengers. So they're becoming to be significant size ships. Then there are some more fun things like kites, and there are several ships now that have these kite installations. You have to have a mast for launching the kite. I would think this is something that seems attractive both in China and Korea, where you have traditions for flying kites, right? Many places in Asia, but these are, supplementary. You couldn't base the propulsion of the ship on kite power, because sometimes it's not blowing that much, but out at sea at least, generally the wind conditions are much better than on land. And depending also on which direction you want to go, if you're going straight towards the wind, I think you'll have problem with the kite. But you don't have to go exactly with the wind either, right? You know, the kite may be, as long as the kite has kind of a power component in the direction you want to go, it is a help. I'm not sure if one can say that this is commercially viable at the moment, but maybe in the future it will be a supplementary type of power source for a ship. So and you can see also some modern cruise ships having sails. Again, more supplementary than the main propulsion source. There are some interesting things. For instance, if you have a cylinder and you spin it and there's a wind like this, you see that where the surface is spinning in the same direction as the wind, the pressure will be less and you get a force in that direction. That's what's called the Magnus effect. When you play tennis, you know, you have the motion of the ball, you have the relative motion between the air and the ball itself, and if it's spinning, you get this transverse force that makes the ball screw, right? That's the same type of effect. So there have been some designs where you have these big masts that are really spinning cylinders that have been used to generate propulsion. But again, I think this is not so very promising. You know, again, you are dependent on having wind, and this is a rather big mechanical installation on the ship, right? But it's kind of interesting that just by spinning a thing, you get a force to move the ship. And of course, and we'll get back to some of these things later on when it comes to high-speed craft. You can reduce the resistance by having an air cushion under the ship, and thereby you don't go so deep into the sea, and so the lifting effect could be useful. This is one thing I picked up, a student project in Gothenburg. It's Chalmers University in Gothenburg, Sweden. And they had a design project for a ferry system to shuttle people across the Gotha River in Gothenburg. So they looked at a system with batteries and solar panels, low resistance. So it's possible to do interesting student projects in this area, certainly. They called this this one Elvis, you know, like Elvis Presley, but Elv in Swedish means river, and this was a river shuttle, so it was kind of a fun name for their project. Yeah. But it's clear that some of these measures we are talking about, they are going to cost something. And then the question is, are people, are the shippers, you know, the cargo owners willing to pay for the extra cost of reducing emissions from ships? And if you look at it, you know, shipping is such an efficient way of moving cargo, and the cost per ton mile is very, very low. And of course, if you look at high value products like a TV or a DVD player or a vacuum cleaner, etc., you know, the shipping cost is a very, very small part of the cost to the consumer. So, in one way, there should be a potential for going towards these more efficient energy and environmentally friendly technologies, even if they cost something, right? So when people become more and more aware of that, you know, this is transported in a green way, maybe have a green mark on it, you know, this is an environmentally friendly product, people are willing to pay more. So in summary, slower speed, larger ships, fleet planning, increase the cargo load factors, utilize the ships better, alternative routing, avoid bad weather, more efficient engines, scrubbing and filtering of exhaust, that is what comes out of the chimney. So scrubbing is cleaning the exhaust. Cleaner fuels, low carbon, like natural gas, low sulfur, fuel cells, alternative fuels like hydrogen. The problem with hydrogen, which in principle is the ideal fuel, because when it oxidizes or you have the combustion, it turns into water, right? But the problem is to store it. You have to, if you are going to store a significant amount of it, you have to have very, very high pressures, which is expensive and dangerous. So, for instance, on some of these rocket launchers, and you know, you use hydrogen, but the pressure may be 700 to 1,000 bars. Of course, then you have to have some pretty sophisticated materials to do that. But it is a problem with hydrogen, and the problem is if you're going to liquefy it, you have to go down to, what is it, 15 degrees or 17 degrees Kelvin?
Around 25.
25 Kelvin. Well, even that is hard to obtain on a large scale. Nuclear. There have been nuclear ships, and of course we have quite a few nuclear submarines. So it's possible to make small nuclear engines. It has been out of merchant shipping for many, many years, even after having been tried, but it may come back sometime. But of course, the public image of nuclear power is still tarnished. You know, it has been damaged by the Chernobyl accident and the 3 Mile Island accident, and so there's been a massive popular movement against nuclear technology. But now people are more and more beginning to see that in fact it could be environmentally friendly if all the nuclear materials are dealt with in a proper way, including the storage after it has been used on board. Yeah. So that's emissions and the discharge we talked about. So this is the summary now. Ballast water, you know, dealing with that, mechanical, chemical, physical ways, more friendly coatings for the ship, ballast-free ship. This is one idea where you actually just open up some channels under the ship and you let the water stream through. I don't think it's completely safe with regard to not bringing alien species, organisms from one place to another, because one can imagine they getting into the ship, staying there for a while, and then coming out again. So I'm not sure. But in one way, at least you get the flushing of the water that you picked up at port. Yeah. Dealing with waste at port. Ships that are safe when it comes to pollution during accidents. Regulatory regimes. Better organization, training and motivation. All of these are important things. And scrapping and dismantling, I talked about. Old and dangerous ships should be eliminated. This is a picture from scrapping on a beach in India. That's how it's done. Almost like ants eating up the ship. So improve the current technologies, search for new technologies, and be innovative, which fits exactly with this course, doesn't it? So if we were to, this is kind of going back a little bit in relation to what we started with in this course, and being systematic about innovating. And there was something called the Osborne technique. Well, maybe you don't remember any longer, but it was kind of a 7-step recipe for dealing with being creative. And define the problem, find facts and data, analyze, assess relevant data, start idea process, involve expertise, and you have to prioritize. If you have several ideas, try to sort out the good ones from the bad ones, and go not to go when you start the development. So now you have a homework problem. So wake up. Within which specific technology area do you think there is a best potential for improving the environmental performance of ships? With best is here meant what area will give the best cost benefit and positive impact. And here I'm saying subjective assessment or opinion is okay. So some of you may be interested in one area, some of you may be interested in something else. I don't want all of you to do the same thing, because it's what gives necessarily the most benefit for a given cost. Right? So all of these things we have talked about now regarding ships, you should think a little bit about it and make up your opinion about what do you think is the most promising technology area. And remember, we can get maybe 20 to 25% reduction of CO2 by implementing good technologies. So what areas are you think should be worked on? And you should write at least 15 sentences about this of your own, right? Not copy your friends. So that is, a couple hundred words or so. I'm not going to count it. Search the web to find this description of technology that would help improving the environmental performance in your selected area from one, right? So if you, for instance, say that I don't fully agree with Paul Bergen. I think that this kite technology is really promising, and so I would like to suggest that, and then you can go to the net and see what you find about it, right? And again, you have to write a little bit about it and include some figures if you like. pictures or graphs or whatever. And then the third one is more optional. Do you have any ideas yourself that is relevant in this context? If so, make a short description, right? So while you're working on this and you get this tremendously good idea, you can write it down and I can give you my opinion about it. So you have 1.5 weeks on this, okay? Does it look like fun or what? That's a challenge to make homework be fun, but I hope you'll show some enthusiasm regarding this. And there's so much information, you know, with the modern age of information and what you can very quickly find on the net. Of course, you have to sort it out and you have to assess it, and some of it is just no good. But you, with your own technical background, you should be able to sort some of these things and see what is good and what is not so good. Okay?